today we're going to do the 6.1 Day 2 notes for slope fields and Euler's method. So just as a review, slope field is a direction field. And it's a direction field for a differential equation. It helps us to see the general shape of the original graph. Okay, so for example number 1, we're going to sketch a slope field for the differential equation y prime equals x minus y for 3 points. So I'm actually going to plot those 3 points first so I know where to put my slope fields. So negative 1, 1, I'm going to put a point, 0, 1, and 1, 1. So I'm going to be finding the slope at each of those points, and I have my formula for slope, and that comes from the derivative. So I'm going to be finding my slope at negative 1, 1, so I'm going to make a list, 0, 1, and at 1, 1. So the slope at negative 1, 1, if I follow the directions here for the formula, it would be x minus y. So negative 1 minus 1, which means I have a slope of negative 2. So if I plot a slope field for that point, it's going to be a little steeper than negative 1. Now I'm going to find the slope at 0, 1. So the slope would be 0 minus 1, so negative 1. So I'm going to plot a slope that represents negative 1. And then my slope at 1, 1 would be 1 minus 1, which is 0. So that would look like a horizontal slope. So the next set of questions, we're going to be looking at 3 different slope fields, and they didn't copy, so I have the graphs right here on the video here you can watch. So we have 3 different slope field graphs, and we have 3 different differential equations. So what I like to do is when I have to match a differential equation with a slope field is I like to look for points on the graphs that are different. Like if I use a point in the first quadrant, they all are positive slopes in the first quadrant, so I'm not going to use a point in the first quadrant. So if I look around, probably a good point if I look would be negative 1, 1. In A graph, it's a negative slope. In B graph, it's a 0 slope. In C graph, it's a positive slope. So that's pretty good. That's going to be a good point to check, negative 1, 1. And if I have to check more, I will. So let's check I. If I use the slope formula to find the slope, I get 0. So that matches up with B. If I do the second differential equation, y prime equals negative 1, so my slope is negative 1, that matches up with A. And then for the third differential equation, I got m equals 1, so that matches up with C. So again, I could check more points, but that's why I pick a point in each graph that's going to be slightly different so that I can compare a lot faster. Okay, on to the back. Now in class for this next question is what we would do is create a group of points to check. So for example, number 3, I'm going to choose 6 points. Actually, I'm going to change it to 9 points. And we're going to find the slope at each of those points and draw a slope field for that. So let's start with the first point here. 0, 0. I have a differential equation at the top here. Y prime equals 2x plus y, so my slope at that point would be 0. So I'm going to plot a 0 slope. My next point is 0, 1. That slope would give me 0 plus 1, so 1. My next point is 0, 2. That slope would give me 2. So a little bit steeper. Okay, my next point is 1, 0. My slope would be 2. Next point is 1, 1. My slope would be 2 times 1 plus 1, so 3, very steep. And then 1, 2. That would give me 2 plus 2, which is 4. Okay, the next 3 points I'm going to check. I've got 2, 0. That slope gives me 4. 2, 1. They're just going to get steeper and steeper, so that slope gives me 5. And at some point it's going to be pretty hard. If you just draw a steep positive line, then you'll get full credit. So next one is 2, 2. That slope gives me 6. So for this question, we're actually going to learn how to use our graphing calculator. Your graphing calculator draws slope fields as well. So what you're going to do is you're going to go to a new graph. So again, if at any point you want to pause the video to get caught up, go ahead and do that. So you're going to be opening up a new document, a new graph, and what we want to do is we want to go to Menu, we want to go to Graph Entry Edit, and all the way at the bottom, number 8, you'll see there's a spot for differential equation. So at the top, this is a little tricky here. So they use y1 instead of y. You can totally change that to y. We're going to be typing in our function here 2x plus y. The problem is that these y's need to match. So if this is y1, this also has to be y1. The other thing you could do, of course, is just change that to just y, and then you can type in just y. So now I'm going to press enter, and you should see a whole group of slope fields come up. And you can zoom out if you want to see more, but you don't have to. So you can see how that matches our graph here, right? We have really steep lines here. They get less steep. We got 0. If I had to make a sketch of a solution curve, and we're going to do that. We're going to draw a solution curve that passes through 1, 1. Here's 1, 1. It's probably going to be pretty steep, flatten out a little bit, and then come back up again. So it's kind of like a lopsided parabola. So I'm going to draw that in over here. Doesn't have to be perfect, just has to be close to the shape that it needs to be. Okay, so let's do the same thing with number 4. This time let's use our calculator. So I'm going to go back to my calculator. This differential equation is negative x plus 1. So I'm going to go to my tab. I'm going to go up, and I'm going to change out that differential equation to negative x plus 1 and hit enter. This time the slope field's a little bit different. So we're going to be drawing a solution curve that passes through the point 2, 4. So I'm going to find 2, 4, mark it off. And I'm going to find that on my calculator as well. It's right about there. So this is more of like an upside down parabola if I go with the curve. And it's going to be a little bit skinnier. So I'm going to draw that in on my paper. And there we have our solution curve. And again, it doesn't have to be perfect, it just has to be pretty close to the shape that it should make. Now, unfortunately on the AP exam, sometimes they will give you differential equations to plot like this, but you won't be able to use your calculator. So the calculator's nice, but you're not going to be able to use it for these types of questions on the AP exam. But in college classes where you're still doing differential equations, this calculator trick comes in really handy. Okay, that is the end of our video.